Hello class. In this video, we look at the sampling distribution of sample means. Let's take a look at this problem. The assets in billions of dollars of the four wealthiest people in a particular country are 42, 29, 23, 18. Assume that samples of size 2 are randomly selected with a replacement from this population of four values. The first part of the problem, we need to find the sampling distribution of the sample means. In the table, values of the sample mean that are the same have been combined. Okay, so we are given the population. The population has four values, 42, 29, 23, 18. Capital N here is the population size, equals 4. And if we use the with the replacement method to take a sample from the population with size 2, then we have 16 different options. Okay, because we can apply the fundamental counting principle. For the first number, we have 4 options. And then when we take the second number, we also have 4 options because this is with replacement. 4 times 4 is 16. And I already have the 16 samples listed here. Is it possible for both two values are 42? Well, 42, 29, 42, 23, 42, 18. Or 29, 42, 29, 29, 29, 23, 29, 18, and so on. I have all the 16 samples written here. And next, we are going to calculate the means of those samples with two values in it. The first sample, 42, 42, the mean is 42. The second sample, we have 42 and 29. The mean of the sample is 35.5. To get a sample mean is very easy. You just need to add the two values together and then divide by 2. Similarly, add 42 and 23 together, divide by 2, we have the mean 32.5. And we have those, I have those means calculated already and listed right here in red, all right? And we are going to, in part A, we are going to create the probability distribution table for sample means, for those red numbers, okay, for those red numbers. Among the 16 sample means, 42 appears once. Since this is a classical model, those samples have the same chance to be taken. So 42, the probability for the sample of size 2 has the mean value equal to 42 is 1 over 16. Those values, those samples have the equal chance to be taken. Is a random sample. And 35.5 appears twice. So 2 over 16 is 1 over 8. Similarly, we can find the probability for those means in the process. So 32.5 appears twice. 32.5 appears twice. 2 over 16 is 1 over 8. And 30 also appears twice. So the probability for x bar equals 30 is 1 over 8 as well. And 29, we only have a 129. So the probability for the sample mean equal to 29 is 1 over 16, and so on. So you complete the table here. You complete the table. This table is the probability distribution table for sample means, for those sample means. Those are all the possible values for the sample means. And in the table, the same values of the sample means that are the same have been combined. We have 235.5, so it only read one time. And the probability is 2 over 16, which is 1 over 8. All right, so that's the first part. Once we have the probability distribution table ready for the sample means, we can enter the table to the TI-84 calculator. So the first column, 42, 35.5, all the possible values for X bar, I put in the first list. And the second list are the probabilities for each possible values of the mean. 0.0625 is 1/16. 0.125 is 1/8. In a calculator, when you enter the fraction 1 divided by 8, it automatically converted to a decimal. And I go to stat calc and make sure the first list is the list and the second list is the frequency. Here's the probability. And we solve, you will have this page. And from this page, you can tell the sample mean, the mean of the sample means. It's a little bit weird, right? The mean of the sample means. In other words, the mean of the distribution of sample means is 28. 28 here is the mean of those sample means, is the mean of those sample means with size 2. And we can easily find the population mean. Population only has 4 values. You add those 4 values together and then divide the sum by 4. And you can do that very quickly. And turns out the population mean is 28. So from this example, you can see the mean of the population is 28. It's the same with the mean of those sample means. Is also 28. And do the sample means target the value of the population mean? Obviously, yes, right? Because it's the same value. In general, do sample means make a good estimates of population means? Why or why not? The sample means does target the population mean. In general, sample means do make good estimates of a population means because the mean is an unbiased estimator. In previous problem, we look at the sampling distribution of standard deviation. We found out standard deviation is not, standard deviation of the samples is not a good estimator. But this one, yes. I hope the explanation clear and helpful.